Imagine pointing humanity's most powerful space telescope toward the nearest known Earth-sized planet beyond our solar system and finding something no one expected. Not a clear sign of life, not a confirmed alien signal, but a mysterious pattern that refuses to fit neatly into any familiar explanation. That is exactly why Proxima b continues to fascinate astronomers around the world. Located just over 4 light-years away, Proxima b orbits the small red dwarf star Proxima Centauri, our Sun's closest stellar neighbor. Since its discovery, the planet has remained one of the most promising places to search for conditions that could support life. Recent observations have once again placed this distant world in the spotlight, not because scientists have confirmed extraterrestrial civilization, but because several unusual features deserve closer investigation. Before jumping to extraordinary conclusions, it's important to understand what researchers are actually studying. Unlike Earth, Proxima b is believed to orbit extremely close to its parent star. Because of this, many scientists think the planet is tidally locked. One hemisphere constantly faces the star, while the opposite side remains in permanent darkness. Such an environment would create dramatic differences in temperature, weather, and atmospheric circulation, making the planet unlike anything in our own solar system. This unique arrangement has inspired many scientific models. If the planet possesses a stable atmosphere, winds could transport heat from the illuminated side to the dark side, potentially creating regions where temperatures are suitable for liquid water. These possibilities make Proxima b one of the most compelling exoplanets ever discovered. Modern observatories, including the James Webb Space Telescope, are capable of studying distant planets in remarkable ways. Although Webb cannot directly photograph cities or individual structures, it can analyze tiny changes in infrared light coming from planetary systems. Every observation adds another piece to an incredibly complex puzzle. During repeated observations, researchers noticed subtle variations in infrared emissions associated with the Proxima Centauri system. These signals immediately attracted attention because they appeared more organized than simple random fluctuations. However, astronomers quickly emphasized that unusual data does not automatically indicate intelligent life. Many natural processes can produce surprising patterns. Powerful stellar flares, changing atmospheric conditions, volcanic activity, clouds, or interactions between magnetic fields can all influence the light astronomers detect from distant worlds. Separating these natural effects from possible technological signatures is one of the greatest challenges in modern astronomy. Still, scientists remain interested because Proxima b occupies one of the most important locations in our cosmic neighborhood. If future missions ever discover convincing evidence of biology beyond Earth, many researchers believe nearby systems like Proxima Centauri would be among the first places where such discoveries could occur. Another reason for the excitement is the planet's position within the star's habitable zone. This region is often described as the distance where temperatures might allow liquid water to exist under the right conditions. Of course, being inside the habitable zone does not guarantee oceans, forests, or life. Countless other factors, including atmospheric composition, radiation levels, and geological activity, play equally important roles. Red dwarf stars present both opportunities and dangers. Although they burn much longer than stars like our Sun, they are also known for producing intense bursts of radiation. These energetic flares could gradually erode a nearby planet's atmosphere, making survival difficult for any living organisms. Whether Proxima b has managed to preserve a protective atmosphere remains one of astronomy's biggest unanswered questions. This is where advanced telescopes become invaluable. Instead of looking for little green aliens or futuristic cities, scientists examine the chemistry of planetary atmospheres. Certain gases can provide clues about geological activity, climate, and potentially even biological processes. Webb's infrared instruments allow astronomers to search for molecules such as water vapor, carbon dioxide, methane, and other compounds that reveal how an alien world functions. Each new observation adds valuable information, even when it raises more questions than answers. For now, the strange signals associated with Proxima b remain exactly what science calls them: interesting observations that require further investigation. They remind us that the universe often surprises us, but careful evidence must always come before extraordinary claims. As exciting as these observations may seem, astronomy has taught us one lesson repeatedly: extraordinary discoveries require extraordinary evidence. Every unusual signal must survive years of careful testing before scientists can confidently explain its origin. That is exactly where the investigation of Proxima b stands today. Researchers are exploring several possibilities that could explain the strange infrared variations. One possibility involves the planet's atmosphere. If thick layers of clouds constantly move across the surface, they could create brightness patterns that appear unusual when viewed from trillions of kilometers away. Another explanation involves volcanic activity. A geologically active planet could release enormous amounts of heat, producing infrared emissions that change over time. Magnetic interactions offer another fascinating possibility. Proxima Centauri is far more active than our Sun. It regularly produces powerful stellar flares capable of flooding nearby planets with radiation. Those energetic outbursts may interact with a planetary atmosphere or magnetic field, creating glowing regions that appear and disappear in complex ways. From Earth, these changing patterns could easily be mistaken for something far more mysterious. Even the smallest amount of background noise can complicate observations. When astronomers observe distant exoplanets, they are trying to separate an incredibly faint planetary signal from the overwhelming brightness of its parent star. That challenge is similar to trying to spot a tiny candle beside an enormous searchlight from thousands of kilometers away. Every observation must be carefully processed to remove interference caused by instruments, cosmic dust, and the star itself. Fortunately, technology continues to improve. Future observatories are being designed specifically to study Earth-sized planets in greater detail. More powerful coronagraphs, advanced adaptive optics, and next-generation space telescopes will allow scientists to examine nearby planetary systems with far greater precision than ever before. These missions may finally answer one of astronomy's greatest questions. Does Proxima b possess a stable atmosphere? Are there oceans hidden beneath clouds? Could biological activity exist there? Or are the unusual signals simply the result of natural processes that we have not yet fully understood? Every new observation brings us one step closer. Scientists are also searching for atmospheric gases that could reveal how the planet functions. Molecules such as oxygen, methane, carbon dioxide, and water vapor leave unique fingerprints in light. By studying those fingerprints, astronomers can reconstruct the chemical makeup of worlds that no spacecraft has ever visited. However, chemistry alone cannot prove intelligent life. Even unusual combinations of gases may result from volcanic eruptions, geological reactions, or environmental conditions completely different from anything found on Earth. That is why researchers avoid making sensational claims until multiple independent observations point toward the same conclusion. Still, the excitement surrounding Proxima b is completely understandable. It is the closest known potentially habitable exoplanet to our solar system. If humanity ever discovers convincing evidence that life exists beyond Earth, nearby worlds like this are among the most likely places where that breakthrough could happen. For now, Proxima b remains an extraordinary mystery. It reminds us that the universe is filled with surprises waiting to be explored. Every telescope, every observation, and every new mission expands our understanding of worlds that once existed only in imagination. Whether the strange infrared patterns eventually turn out to be atmospheric phenomena, geological activity, or something no one has yet considered, the scientific journey itself is just as important as the final answer. History has shown that many of astronomy's greatest discoveries began with a single unexplained observation. Today, Proxima b has once again captured the attention of scientists around the world. Tomorrow, improved technology may reveal the true nature of this remarkable neighboring planet. Until then, the mystery remains unsolved, but the search continues. And perhaps that is the most exciting part of all. Somewhere among the countless stars surrounding our solar system, the next great discovery could already be waiting for us to find.